Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod. Hello viewers, in last session we have seen the basics of control systems where we have learned what a system is, what a control system is, followed by open loop and closed loop systems. In today's session, we'll see the examples of open loop system and a closed loop system. Now, considering this open loop system, here we have taken a generalized example where we are supposed to control the traffic by controlling the time slots of the traffic signals. And this is not that reliable system because we are not considering the traffic density. Now coming to our closed loop system, we consider the traffic density also, which again depending on this we can vary the time slots of the traffic signal depending on which we can control the traffic. So considering the open loop system, there is no sort of feedback to measure the traffic density. When in closed loop system, we do have a feedback to measure the traffic density, basing on which you can vary the time slots, basing on which you can control the traffic efficiently. This is a generalized example for open loop and closed loop system. Now we'll see the mathematical model of control system. Now for a control system, usually we know a control system is a combination of certain components in a particular order to perform a specific function. You call it as a control system. For example, considering a control system having two components, say here 1 and 2, where we have the input and a final output here. And output of this component 1 is nothing but input for the component 2 here. So how do we relate the output for this component 1 and the input to this? That is in terms of differential equations. Just like that, even for the component 2 here, we can relate the output and input in terms of differential equation. So a set of differential equations will be governing this particular control system. Now we'll see the mathematical model for linear time invariant system. Okay, now for a linear system, definitely that particular system should hold good the principle of homogeneity. Let's see what it is. Now for example, if we do consider a linear system, say if this is a linear system and x1 is the input given to this and y1 is the output. Now if the input is ax1, say, you get the output ay1. Okay, now for a linear system, the very first thing is it should satisfy the principle, or it should follow the principle of homogeneity. Now the second principle of superposition. For example, we do consider a linear system, say, where x1 is the input and y1 is the output. And for the same system, x2 is the input, y2 is the output. So definitely the linear combination of x1 and x2 for the same system, x1 plus x2, combination of these two inputs would give us an output of linear combination of these outputs y1 plus y2. So for a linear system, definitely principle of homogeneity and principle of superposition should hold good. Now we'll see the mathematical model for linear time invariant system, that is for a single input, single output system. Okay, as we already know that we can relate the input and output of a particular component in terms of differential equation. By solving all the set of differential equation governing that particular control system will give us a particular frame. That particular frame, you call it as a transfer function. Okay, now that is equal to Laplace transform of output by Laplace transform of input. Just for convenience sake, I have written like this. Okay, and that too we have a condition here called zero initial condition. This initial condition would represent linearity of the system. So in today's session, we have seen the examples of open loop system and closed loop system, and then we have seen what a linearity is, that is following the principle of homogeneity and superposition, and also we have seen the final expression relating the output and input, that is nothing but transfer function. In the next session we'll see the mathematical model, that is nothing but we come to know about the mechanical system and solving that, so that we finally get the mathematical approach for that mechanical systems. If you do have any suggestions and queries, please mention in the comment box below. Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.